Deep in the sweltering humidity of the Florida Everglades, a Burmese python is wrapping its jaws around the snout of a fully grown white-tailed deer. If you look at this scene purely by the numbers, it makes absolutely no sense. The snake's head is roughly the size of a grapefruit. The deer it is trying to consume weighs 70 pounds. Logically, geometrically, and physically, this meal should be impossible. But over the next 2 hours, the python does something that defies our understanding of how eating is supposed to work. It does not take a single bite. It does not tear the flesh. It does not chew. Instead, it slowly, methodically unhinges its lower jaw. It walks its backwards-facing teeth over the animal's shoulders, and it stretches its own skin until the entire deer, the heavy hooves, the sharp antlers, the thick fur, and the dense bone, disappears down its throat in one massive, terrifying gulp. Most people watch a video like this and assume it is just a crude, messy animal shortcut. They look at it as a biological freak show, a primitive flaw in nature's design. But what is actually happening inside that snake's body is a masterclass in survival mathematics. It is a biological strategy, so extreme, so brilliantly engineered, and so violently efficient that once you understand how it works, you will never look at your own dinner plate the same way again. Because the real reason predators swallow their prey whole isn't just about how they hunt. It is about a terrifying evolutionary trade-off, a structural compromise that is actively hiding inside your own throat right now. And by the end of this video, you will realize that a deeply ancient, predator-like panic is still controlling how you eat every single day, whether you realize it or not. Let's start with the most obvious question, the question that has puzzled early naturalists for centuries. Why don't the world's most lethal predators just chew their food? Take a saltwater crocodile. It possesses the strongest bite force ever recorded on Earth, easily capable of crushing a steel car door. Yet, despite that immense power, it cannot grind a single piece of meat. Its jaw can only clamp and roll. Watch a pelican tip its head back, and a whole, thrashing fish just vanishes. Watch a monitor lizard swallow large rodents completely intact. On the surface, this looks incredibly lazy. We are taught from childhood that chewing breaks food down, increases surface area, and makes it vastly easier to digest. Skipping that step seems like a massive, dangerous evolutionary mistake. But evolution does not make mistakes. It makes ruthless adaptations based on the currency of the wild. And in the wild, the most expensive, most dangerous currency an animal can ever spend is time. Imagine you are a lioness or a leopard. You have just expended a massive percentage of your daily caloric budget to sprint, tackle, and suffocate a heavy gazelle. You are entirely exhausted. Your muscles are burning. Your heart is pounding against your ribs. But the hunt isn't the most dangerous part of your day. The most dangerous part is what happens right now. The smell of fresh blood is drifting on the wind. Hyenas are watching from the tree line, calculating your exhaustion. Vultures are beginning to circle overhead, literally pointing a giant, undeniable arrow in the sky toward your exact location. Other rival predators, maybe a larger male lion, are moving in. Every single second you spend leisurely chewing your food, breaking it down piece by piece, is a second someone else could steal your kill. Or worse, it is a second where your head is down, your guard is compromised, and you could be attacked. So nature did something brutal. It optimized many predators not for the most comfortable way to eat, but for the fastest possible way to get biological mass into a secure vault where nobody else can steal it. Your stomach is a vault. Once the meat is inside, it is yours. Nothing can take it back. Evolution never built a chewing mechanism for snakes or crocodiles, because chewing was never the priority. Speed of extraction from a dangerous environment was. But avoiding danger is only half of the equation. If you think swallowing whole is just about speed, you are missing the most brilliant engineering trick in the animal kingdom. Here is the twist that most people completely overlook. Swallowing prey whole isn't just about safety. It is about achieving a level of nutritional extraction that chewing could never accomplish. Think about a killer whale catching a seal, or a heron spearing a fish. If they were to sit there and chew, what happens? They would tear the meat, yes. But they would also fracture the bones, shred the cartilage, and scatter the scales. In a watery environment, or even out on the dirt of the savanna, chewing is messy. Tiny bone fragments, rich in calcium and vital minerals, would drift away in the current or fall into the mud. Nutrient-dense bone marrow would be washed away. Chewing, by its very nature, wastes a percentage of the meal. But when a predator swallows that fish or that seal completely whole, the entire animal becomes a perfectly sealed package. Nothing is dropped. Nothing is lost to the environment. The predator's stomach becomes a closed-loop system where every single milligram of calcium, phosphorus, and protein is trapped and completely absorbed over hours and days. The mouth would only get in the way of this efficiency. But simply getting a fully intact skeleton into the stomach is only the first step. What happens next inside the predator's body is a process that should genuinely disturb you. Digesting an entire intact skeleton, wrapped in thick muscle, hooves, and fur, requires biological weaponry. If you or I accidentally swallow a small, sharp fish bone, it can easily puncture our intestines, cause internal bleeding, and send us straight to the emergency room. But a predator that swallows whole operates a digestive system that is closer to an industrial chemical vat than a normal stomach. A python's gastric juices sit at a pH level of roughly 1.5. That is highly concentrated hydrochloric acid. It is acidic enough to completely dissolve solid bone, heavy hooves, and even razor-sharp porcupine quills without leaving a trace. But it takes a massive, almost incomprehensible amount of energy to run an acid bath that powerful. And this is where researchers studying Burmese pythons discovered something almost unbelievable. This is not a passive digestive process. This is the predator's body going to total war with what it just swallowed. Within 48 hours of swallowing a massive meal, a python's internal organs physically mutate. Its heart literally grows by up to 40% just to pump enough blood to the stomach. Its intestines thicken and lengthen. Its liver doubles in size. Its metabolic rate spikes by an astonishing 40-fold. For context, a human being's metabolism barely doubles when we are sprinting at absolute top speed. The python's blood literally changes color. It turns milky white because it becomes so deeply saturated with extracted fat from the prey. The entire gut essentially rebuilds itself. And then, once the deer is fully dissolved and absorbed, weeks later, the snake does something even stranger. It shuts the factory down. Its heart, liver, and intestines shrink back down to their original, tiny baseline sizes. The snake goes into power-saving mode, sometimes not needing to eat again for another 6 months. They are essentially switching their internal organs on and off like heavy machinery, powering up only when there is a job to do. It is an incredibly brilliant, mathematically perfect system. Fast, safe, zero waste. Which brings up a rather dark, uncomfortable question about your own biology. If swallowing food whole is vastly faster, infinitely safer in a dangerous environment, and perfectly extracts every last drop of nutrition from the bones, why can't you do it? Why do you have to sit there, boringly chewing a piece of steak 30 times before you can swallow it? The brutal truth is that you actually cannot safely swallow food whole. If you try, you will likely die. And there is a very specific, structural reason why. Your throat was fundamentally redesigned by evolution to do something entirely different. Inside your neck, right now, is a tiny, delicate flap of cartilage called the epiglottis. Its entire job is to quickly seal off your windpipe every single time you swallow a bite of food, directing the food into your stomach instead of your lungs. It is a highly sensitive system. And it fails all the time. Swallow something too big, or swallow too fast while distracted, and the food slips past the flap, blocking your airway. This is exactly why choking is one of the leading causes of accidental death in humans. A snake does not have this problem. A snake has a highly specialized muscular tube called a glottis that it can literally extend out the side of its mouth like a biological snorkel. This allows the snake to keep breathing perfectly fine even while its throat is entirely blocked by a dead animal for hours. So why didn't you get a snorkel? Why did you get a dangerous, easily blocked, highly vulnerable airway? Because you paid a biological price for a completely different superpower. Millions of years ago, human ancestors started walking upright. As we evolved, our skulls shifted, our jaws shrank, and most importantly, our voice box, the larynx, dropped much lower in the throat. This lowered voice box is exactly what makes you so incredibly vulnerable to choking. It created a dangerous intersection between where you breathe and where you eat. But it is also exactly what allows you to speak. You traded the ability to safely gulp down raw meat for the ability to form complex vowels, to whisper, to shout, to coordinate hunting strategies with your tribe, to tell stories. Evolution was forced to choose between a throat built for speed swallowing and a throat built for complex communication. In humans, it chose the voice. But if we lost the ability to swallow food fast and safe, how did we survive? If we had to sit out in the open, slowly chewing our food, why didn't we just get eaten by predators? Because humans found a second cheat code, an innovation that allowed us to stop chewing like wild animals. We outsourced our digestion to the outside world. We discovered fire. Cooking is essentially pre-digestion. When you throw a raw piece of meat or a tough, fibrous root onto a fire, the intense heat breaks down the tough proteins and softens the fibers before the food ever reaches your mouth. You don't need stomach acid with a pH of 1. You don't need backward-facing teeth to drag a carcass down your throat. The fire did the heavy biological lifting for you. Because we learned to cook our food, our human ancestors didn't have to spend 6 to 8 hours a day aggressively chewing raw foliage like a gorilla. That freed up a massive, unprecedented amount of daily calories. And our bodies took all that leftover energy, all the calories we didn't spend chewing and digesting, and pumped it straight up into our skulls. It funded the growth of the massive, immensely energy-hungry human brain. You are only smart enough to understand the concepts in this video because your ancestors learned how to cook, which allowed them to chew less, which gave them the energy to think more. But this is where the story shifts from biology to psychology. Because for humans, chewing didn't just become easier, it became deeply emotional. Look at how humans in healthy societies actually eat. We sit down, we stop moving. We share a table with people we trust. We talk while we chew. Anthropologists studying early human tribes found something incredible. The exact moment humans started eating in groups around a shared campfire, survival rates skyrocketed. Why? Because a slow meal shared with others meant someone else was actively watching your back while you were vulnerable. Humans didn't out-evolve the danger of eating in the wild. We just outsourced our safety to each other. Across the entire animal kingdom, scientists have proven that chewing time correlates almost perfectly with how safe an animal feels. Animals at the very top of the food chain, or animals that can drag their food into a hidden, secure burrow, take their time. They chew. Animals exposed in the open, competing over a fresh kill, chew less and swallow as fast as they can. Fast eating is a stress response. It is a direct, biological readout of how dangerous an animal's environment is. Which raises a deeply uncomfortable question about modern human life today. What does it say about us that we evolved into a species that earned the rare privilege to sit and chew slowly with our guard down, only to completely throw that privilege away? Modern life has quietly, invisibly dragged you halfway back toward the predator strategy without you ever noticing. Think about your own life this week, eating a sandwich with one hand while driving your car in heavy traffic, inhaling a salad at your desk while staring at a stressful spreadsheet, eating in front of a glowing screen, constantly distracted, barely chewing, barely even tasting the food. Researchers who study human eating speed have found a disturbing pattern. People who are stressed, anxious, or distracted while eating chew significantly fewer times per bite than people eating with full attention. You are not being hunted by a hyena. You are not worried a leopard is going to drop from the office ceiling and steal your lunch. But your amygdala, the ancient, primal fear center of your brain, doesn't know the difference. Your nervous system is treating the meal as an obstacle, something to get through as quickly as possible rather than something to savor safely. The threat has simply changed shape. It is a buzzing smartphone notification instead of a rival predator. It is a looming project deadline instead of a ticking biological clock. It is financial stress instead of physical starvation. But the ancient wiring underneath your skin reacts the exact same way. Faster bites, less chewing, less presence. A desperate rush to get the calories secured in the vault so you can get back to scanning the horizon for danger. And ironically, this is exactly why choking has become more common in the very environments designed to be the safest. Eating while stressed, eating while rushing, treating a meal as an inconvenience rather than a biological necessity. Every single time you inhale your food without thinking, you are recreating, in miniature, the exact same vulnerability a wild animal feels out in the open. Except, unlike a python or a crocodile, you do not have the throat or the stomach acid to survive a mistake. Your body was built for peace, but your mind is running a wartime script. Now, imagine you are there, 40,000 years ago, crouched at the edge of a flickering fire with a piece of roasted meat in your hand. Somewhere out in the pitch-black dark, beyond the light of the flames, something is moving. Something is watching you. You don't chew slowly. You tear off a chunk, swallow it half-broken, and keep your eyes locked on the tree line. That deep primal instinct never fully left you. It is still folded somewhere inside your nervous system. It is the reason why stress eating so often looks like fast, frantic, barely chewed eating. Under pressure, the human brain reverts to gulping food the exact same way a starving, paranoid predator does. You are not broken when that happens. You are just remembering. The real answer to why predators swallow meat whole was never really about the shape of their teeth, the strength of their jaws, or the acid in their stomachs. Those are just the tools. The real answer is about what a brutal world demands of the things that live in it. A python swallows because a slow bite is a death sentence in the swamp. A crocodile gulps its food because time at the surface is time exposed. And you, sitting at your dinner table tonight, get to chew slowly because somewhere in the brutal, violent history of human evolution, your ancestors fought their way into a world where they finally, briefly, didn't have to eat like they were being hunted. The privilege of chewing is the privilege of safety. The next time you sit down to a meal, take a breath, look around, and actually use it.